For today, discuss tayo ng second method of transportation, yung tinatawag na MODI method or modified distribution method. Okay, so the MODI or modified distribution method of transportation problem. In this method, we have to add a new row above the table for cost factors and new column to the depth of the table. We make use of B sub I or B sub I for cost factors and of supply and W sub J for cost factors of demand. The key to the use of MODI is to utilize the occupied cells for each B sub I and W sub J values. And then use these values to calculate the net contribution of the vacant cells. Let's consider the example last time and solve the problem using MODI method. The problem last time is the FCJD Gravel and Supply has received a contract to supply gravel to 3 new road projects located in 3 different locations. Project A needs 174 truckloads, Project B 204 truckloads, and Project C 143. The company has 3 gravel warehouses located in 3 different places. Warehouse 1 has 158 truckloads available, Warehouse 2 has 184, and Warehouse 3 has 179. The cost of transportation from warehouse to projects are: from Warehouse 1, the 2 projects A, B, C, we have $4, $8, and $8 per truckload respectively. For Warehouse 2, we have $16, $24, $16, and from Warehouse 3, 8, 16, 24 respectively. The objective is to design a plan of distribution that will minimize the cost of transportation. This is the problem last time, but this time I will solve this problem using modified distribution method, okay, or MODI method. So table number 1 is ready. Table number 1. Okay, so initially kailangan natin i-distribute yung demand ng bawat projects natin gamit ang ating supply. So let's distribute. Okay, so let's give 158 to project A from warehouse 1. So kulang siya ng 16, that is from warehouse 2. So check natin. So that's 174. Yes. Okay, so bibigay natin yung natira sa project B from warehouse 2. So that's 184 minus 16 is 168. So 168. Then from 168, dagdagan natin siya ng ilan para maging 204. So kailangan mong dagdagan ng 204 minus 168. 36. So lagyan mo ng 36. Tapos eksakto 143. By the way, alam naman natin from the start that this is balanced sa 521. Sa 521. Okay. So from that, we can compute the cost of transportation. By the way, this is now COT. Alam mo na ibig sabihin yan. $8,928 to. Pagkakaalala ko. Okay, so ayun yung pag-distribute tsaka yung pag-compute ng cost of transportation ay alam mo na yan from our part 1. So, ito yung bago. Okay, so, itong rows na to, gagawin natin B sub I. So, that's B sub 1, B sub 2, B sub 3. Ito naman yung W sub 1, W sub 2, W sub 3. So, ito yung bago ngayon. Ngayon, focus ka sa occupied cell, no? Itong equation na to, gagawin natin yung equation. So, ito yon, first occupied natin yung 1A. That is the intersection of B1, W1. So, B1 plus W1 equals 4. Saan galing yung 4? That is the cost of transportation from warehouse 1 to project A. Another occupied is 2A. So, that's the intersection of B2 tsaka W1. So, this is B2 plus W1 equals 16. Next is B2 plus W2 equals 24. Next is B3 plus W2, so this occupied cell, equals 16. And B3 plus W3 equals 24. Alam ko naman na nagets mo kung paano gawin yung equation. No? Again, focus tayo sa occupied cells. So, the number of occupied cells will give the number of equations. So, dahil 5 yung occupied cells natin, 1, 2, 3, 4, 5. So, ibig sabihin, 5 yung equations na mabobuo mo. Okay? So, from that, kukwentahin natin yung value ng B1 to W3. When I say B1 to W3, kasama na dun yung B2, B3, W1, W2. Okay? Okay, so kung mapapansin mo, hindi to system of linear equation dahil walang dalawang equation na magkaparehas ng argument about their variables. So for example, B1, W1, makikita mo lang yan sa equation na to. Sa ibang equation, walang ibang equation na magkasama yung B1 tsaka W1. From that, ito yung technique niyan. So let always now that B1 is equals to 0. So if your B1 is equals to 0, so from that, mabubuo na natin yung, o makukuha na natin yung value ng W1, W2, tsaka yung mga unknown B1, B2, tsaka B3. Again, you always let that B1 is 0. Yan na yung technique na gagamitin natin palagi. Okay, so from equation number 1, if you let your B1 is 0, obviously your W1 is 4. That's from equation 1. Okay, since W1 is 4, from equation number 2, you can determine the value of B2, and that is 12. Because that is 16 minus 4. Now, because meron ka ng B2 from equation number 3, W2 is also 12. Because if you transpose the value of B2 to the other side, it will give you 24 minus 12. And W2 is equals to 12. Now, because meron ka ng W2, so it follows that from equation number 4, you can determine B3 as 4. Okay, so what is W3? Dahil meron ka ng B3 na 4, from equation number 5, B3 plus W3 equals 24, you can determine that your W3 is 20. Okay, so by letting your B1 is 0, kung wala namang problema, makukuha mo lahat ng B's tsaka W's. So mamaya papasok yung problema, mamaya yun sa baba. Okay? Mamaya natin pag-uusapan kung paano yung solve yung problema kung maputol yung equation mo. Pero ito hindi. Dahil ito ay balance at generated. Okay? So ang gagawin natin is lilista natin yung value ng B1 hanggang B3, W1 hanggang W3. So this is 0, 12, 4, is 0. W4 is 4, 12, 20. Okay, from that, papasok tayo sa computation for improvement. Dito na lang ako sa taas kasi bababa ako. Mag-CFI ako dito. Dapat dito pag binaba ako, hindi ko makikita yung sa taas. Okay, so ganun pa rin. Ilista mo lahat ng, you list down all the vacant cells. So, 1B, 1C, 2C, 2C, 3A. So, meron kang 4 na vacant cells. At paano kunin yung CFI dito? So, sa 1B, ito yung 1B. So, from this cost, 8, ima-minus mo yung value ng B at minus yung value ng W na nag-intersect doon sa vacant cell na yon. So, it follows that this is 8 minus B minus 0 tapos minus 12 and that is negative 4. Okay? Ulit. Ito yung 8 dahil ito ay intersection ng B1 at W2, i-minus mo yung B1 tsaka yung W2. So, minus 0, minus 12. The cost of the vacant minus 0, minus 12. So, sa 1C naman is 8 minus 0 minus 20 equals negative 12. Sa 2C, that is 16 minus 12. 16 minus 12 minus 20 is negative 16. Sa 3A is 8 minus 4 minus 4 will give you 0. Okay? So, kung mapapansin mo, kung babalikan mo yung solution natin ng stepping stone method, same yung nangyari sa CFI sa table number 1. Pero again, iba yung procedure dito. Hindi tayo gumagamit ng yung ikot-ikot natin. Ito, basta nagawa mo yung equation, mamiminimis mo yung ikot. So, from that, pipiliin natin yung 2C. Alam mo kung bakit. Kasi 2C is the most negative vacant cell. That is negative 16. So, ang gagawin mo is same tayo. So, gawin natin yung table 2. Ito yung 2C. 2C, lilipat yung 143. So, lipat ko muna yung, ito yung 2C. Di ba? Ito ikot ng 2C. So, 158.16. Bigay ko muna, 158.16. 158.16. Tapos, ilipat yung 143 dito. Tapos, adjust tayo. Adjust. Okay. Adjust na tayo. Okay. So, kung 184, 143 na to. Ito, okay na rin to. So, lalagay ko dito yung 179. Dahil wala ka nang pwedeng lagyan bukod sa project B. Pero kulang pa yun ng 204 minus 179. 25. Okay. So, buo na uli. 521, 521. Ito yung paglipat ng table. Papuntang table 2. So, ganun ulit. Repetitive procedure. Gawa ka ng B1, B2, B3. W1, W2, W3. Tapos gawa ka equation. B1 plus W1 equals 4. B2 plus W1 equals 16. B2 plus W2 equals 24. B2 plus W3 equals 16. At V3 plus W2 equals 16. Okay, from that, ililit natin ulit. We always let that B1 is 0. Then, kwentahin natin yung B2, B3, W1, W2, W3. Okay? If this is 0, W1 is 4. If this is 4, B2 is 12. If B2 is 12, W2 is also 12. If W2 is 12, B3 is 4. If B2 is 12, W3 is also 4. Okay? So, kung mapapansin mo, iba yung values ng DI natin at WJ sa table number 1 compare sa table number 2. So, this is 0, 12, 4, 4, 12, 4. CFI, 1B, 1C, 3A, 3C. C1B ay 8 minus 0 minus 12, that is negative 4. This is 8 minus 0 minus 4, this is 4. This is 8 minus 4 minus 4 is 0. 3C is 24 minus 4 minus 4 is 16. So, kung babalikan mo ulit yung solution ng stepping stone method, makikita mo na parehas din sila. So, anong ibig sabihin nun? Kung ilan yung table ng stepping stone method, yung table number 4 tayo natapos doon. Ibig sabihin, dito, table number 4 ka rin natatapos. Okay? Continue mo to hanggang table 4 at alam mo na yung conclusion niya. Sulat mo yung conclusion. Siyempre, same conclusion yan kagaya ng nakaraan dahil same problem naman yung sinod natin. Okay? So, ganyan gumagana yung modified distribution method o tinatawag na MODI. So, ito ay mas convenient gamitin dahil hindi ka ikot ng ikot. Pero hindi mo po pwedeng kalimutan yung ikot dahil kailangan mo rin yun sa pagpili ng most negative. Alamin mo yung unaffected sa affected cells. Alam mo na yun. Okay? So, dalawang table na lang yan. Tapos na yan. Okay? Continue tayo. So, that's MODI. So, now, let's talk about unbalanced transportation problem. In actual practice, it seldom happens that the quantity demanded is just equal to the quantity supplied. Under normal situation, transportation problem come as unbalanced problem. But since we can only handle a balanced table, we must find a way of converting an unbalanced table to balanced one. This can be done by the use of dummy. A dummy is something we pretend to exist, although in reality, it does not. Okay, so, ano ibig sabihin nito yung binasa ko? So, ang sinasabi dito, yung mga problem natin sa transportation, napakabihirang mangyari na yung bibigyan ka palagi ng balance, transportation problem. So, mas madalas mangyari in actual practice na unbalance yung ibibigay sa'yo o may encounter mo. At paano mo isosolve yun? Ang sabi dito, dahil kaya naman nating mag-handle ng balance, para ma-solve yung unbalance, kailangan maghanap ka ng paraan para yung unbalance maging balance. At mangyayari yon kapag gumamit ka ng dummy. Again, a dummy is something we pretend to exist, although in reality, it does not. Okay, pag-usapan muna natin yung dalawang klaseng unbalanced transportation problem. So, dalawa yan. If we let that D be demand and S be supply, so pwedeng mangyari 1 or 2. It's either yung D mo ay greater than supply or yung S mo ay greater than demand. So, ito yun. Ito rin yun. Sinakto ko na. If the demand is greater than the supply units, that's number 1. If the supply units is greater than the demand, Sa economics, may tawag tayo dito sa dalawang to. So, sa economics, ang tawag natin kapag yung demand ay mas mataas kaysa supply, may condition, economic condition na nangyayari dyan. Tawag dyan shortage. Okay? Kapag naman yung supply, mas mataas ang demand, ang tawag doon surplus. Okay? Mas marami yung supply kaysa sa demand, surplus yon. Okay? Kapag naman mas marami yung demand kaysa supply, shortage yon. Okay, so paano gagawin natin doon? Ngayon, ang sabi dito, number 1, ang solution dyan, use dummy supply sa number 1. Sa number 2 naman, use dummy demand. Para mas maintindihan mo, pasok tayo sa example. So sa example natin, kung i-add natin yung supply nito, 76 plus 82 plus 77, 235. Yung supply natin dito ay 235. Samantalang yung demand natin 72 plus 102 plus 41, 215 lang. So 215. So mas mataas yung supply kaysa sa demand. So dahil mas mataas yung supply kaysa demand, ito ay surplus problem. Surplus problem. At lalagay mo yung UNB dito to indicate that this problem is unbalanced. Now, gagawa tayo ng paraan. Dahil nasa number 2 tayo, ibig sabihin ng number 2, S is greater than D, so surplus, gagamit tayo ng dummy demand. So, from 235 tsaka 215, magdadagdag tayo ng 20 na demand. So, gagawa tayo ng project D dito. Kunwari, may project D, tapos ang kanyang demand ay 20. Bibilugan mo yan to indicate dummy. Hindi yan totoo. Gagawan lang natin ng paraan para ma-solve natin yung problem. Ngayon, may 4 tayo dito. Tapos, wala na tayong 4 dito. Bali itong row na to ay buburahin ko gamit ang shading. Kasi ganyan yung mangyayari sa problem nyo. Kung sakali magbigay ako ng unbalance. Ayan. Ngayon, itong cost, ito ba, itong 4, 8, 8 na to ay mga cost. Dahil ito ay dami lang, ang cost niyan 0. Assume 0 yan para hindi makagulo. Okay, ngayon, ito ay balance na. Kasama yung 20 sa 235, 235. Now, this is balance. From that, dahil balance na yan, pwede ka nang gumamit ng MODI dyan or stepping stone method. Okay? So, ang concern lang natin dito is i-convert natin yung unbalance sa balance. So, yung other side naman ng unbalance, yung number 1, same procedure lang. Kaya lang, ang idadagdag mo doon, hindi demand, supply ang idadagdag mo. Ngayon, anong implication nito? Dahil tayo ay itong problem na to, itong ginawa ko ngayon, example ko. Dahil ito ay surplus problem, ang ibig sabihin, may matitira kang supply sa either warehouse 1, warehouse 2, warehouse 3. At I can tell you na yung matitira sa'yo dyan ay 20 dahil nga sobra ka ng 20 supply. Ngayon, at the end of the conclusion, kailangan mong banggitin sa conclusion mo, aside from the distribution, at the end, kailangan mong banggitin kung nasaan yung supply na sobra. Kung nasa warehouse 1, warehouse 2, or warehouse 3. Maaaring nasa isang warehouse lang, nandun yung buong 20, or maaaring nandun sa warehouse 1, warehouse 2, warehouse 3 din. Kunyari, sa warehouse 1 may 5, sa warehouse 2 may 5, sa warehouse 3 may 10. Pwede, babanggitin mo yon na meron kang surplus or supply pang natitira doon sa inyong warehouse. Okay? Okay. Ito ay tinitreat as balance lang. Kaya nga sabi ko pagka na-balance mo na, pwede ka nang gumamit ng MODI or SSM. So, yan yung mangyayari dyan. Okay? Okay. So, pasok ngayon tayo sa, ano ba masasabi ko dito? Kung sakali naman number one, so shortage yun, sasabihin mo naman doon sa conclusion mo at the end, pag-solve mo, kung saan mga projects ka may kulang. Kung ilang sa project A, ilan sa project B, ang shortage mo, or ilan sa project C. Okay, so gaya na sabi ko nung last time, kailangan priority mo yung iyong customer. Kaya lang wala ka namang magagawa kung kulang ang iyong supply. Okay, may magagawa naman yun. Pero i-maximize mo yung profit gamit yung i-minimize mo yung cost gamit yung mga supply mo. So ito yun, and ganyan yun. Okay? Okay, so another problem is hindi pa rin porket unbalance at naging balance, okay ka na. May mga pagkakataon na magkakaroon ka ng problema at mahihinto ka. Ang tawag doon, dahil hindi na makaikot kung gagamit ka ng SSM or hindi ka na makakuha ng value kung gagamit ka ng MODI. Napuputol. Pag napuputol yung proseso, ito yung isang dahilan. Yung pagiging degenerated transportation problem niya. Ang sabi dito, if the total number of used cell is not equal to the number of rows plus number of columns minus 1, degeneracy in transportation occur. Degeneracy may occur in an initial solution or table number 1 or in a subsequent solution. Degenerate table is one cannot be improved due to lack of entries. Okay, now balikan natin yung problem natin. Original problem natin. Dito, yung number of occupied mo, yung number of occupied cell mo dito or yung used cell, 1, 2, 3, 4, 5 is 5. Kung titignan mo yung number of rows mo dyan, 3. Yung number of rows mo, 3. Ganun din yung number of columns, 3. So para malaman mo, degenerated test, i-add mo yung number of rows plus number of columns minus 1, dapat yan ay equal sa number of occupied cell. So ito ay 6 plus 6, 3 plus 3 minus 1 is 5. 5 ba yung occupied mo? Yes. So kaya hindi ka nagkakaproblema sa problem na to kasi ito ay generated. Kapag hindi sila equal, degenerated yon. At pag sinabi natin degenerated, lack of entries yon. Hindi sobra. Hindi mo pwedeng sobra yung entries mo. Lack of entries. Okay? Dapat alam mo kung ilan dapat ang occupied cells mo para maging generated yung problem. Hindi ka pwedeng sumobra doon. Pero sometimes, again, kulang nga. Kapag kulang, ibig sabihin degenerated. At pwede yun mangyari sa dalawang pagkakataon. Pwede yung mangyari sa initial solution. Pag-usapan natin. In this particular case, the of degeneracy arises when in using northwest method of initial distribution. Yung ginagawa natin distribution tawag ng northwest method. Column requirement and row requirement are satisfied simultaneously. Thus, breaking the stair-step pattern, to resolve this, we assign a zero entry to one of the unused cell. Example below illustrate. Okay. Kung titignan natin, check muna natin kung balance or unbalanced to. So, 55, 80, 110. Ito, 80, 110. So, balance to. Okay. Kung balance to, distribute natin. Bigay mo yung 35 dito. Dito na 20, bigay mo yung 25, bigay mo yung 30. Kung mapapansin natin, yung number of rows nito, 3. Yung number of columns nito, 3. Pero kung bibilangin mo yung number of occupied cell nito, 4 lang. hindi siya masasatisfy sa number of rows plus number of columns minus 1 equals number of occupied cell. Kasi ito 5, samantalang ito 4. So, ibig sabihin, degenerated to. That's how to check. Ngayon, kung gusto mo, visual lang, merong sinabi dito, kailangan mo makita yung stair-step pattern. So, kung mapapansin mo, kung maghahanap ka ng stair-step pattern, ito yung stair-step pattern. So, wala ka dito. So, may problema ka. So, or wala ka dito. Okay? So, ang ibig sabihin nun, kulang nga, di ba? Dadagdagan natin. At ilan na idadagdag natin? Alam natin kung ilan dapat ang idadagdag natin dahil you are expecting 5 but the number of occupied cell is only 4. So, kailangan mo lang magdagdag ng isa. At ang idadagdag mo ay 0. Yung 0 and 3. Para mabuo mo lang yung stair-step pattern. Pwede dito sa 2C or pwede sa 3B. It's up to you kung saan ka magdadagdag. Kasi stair din naman yon. Okay? Okay, syempre dahil meron kang option, maaaring magkaiba kayo ng number of tables nung mga classmates mo. Maaaring mas matapos ka ng mas mabilis or mas matagal. When I say mas matagal, kasi nga magkaiba kayo, may options na dito. May option dito sa paglalagay ng 0. At yung 0 niya, pumupwesto yan sa tamang pwesto. Okay? So, again, kailangan mo ngayon at this point, kailangan mo palagi magbilang ng occupied cell para alam mo kung gagana o hindi. Ngayon, ano bang ibig sabihin? Kung hindi mo napansin, siya mismo magsasabi sa iyo na degenerated yan in the middle of your solution kasi hihinto yan. Kung si stepping stone method ang gagamitin mo, kahit umikot ka using spider, hindi ka makakaikot. Kung si modified distribution naman ang gagamitin mo, meron kang value either B or W na hindi mo makukuha kasi mapuputol nga dahil kulang nga. At ngayon, sa initial solution, kung sa initial solution, alam mo na kung paano gagawin. Magdadagdag ka lang ng 0. Okay, hindi palaging isa ang idadagdag mo. Pwedeng 2, 3, pwedeng 4, or so on. Basta wag kang lalagpas sa ito. Alam mo kasi dapat ang ini-expect mo sa expected number of occupied cell. Okay? Okay, continue tayo. The second part of degeneracy, ang ibig sabihin nito, subsequent solution, hindi siya mangyayari sa first table. Mangyayari siya sa ibang tables in the middle of your solution. Some transportation problem begin with an initial table that is not degenerated, which is generated. But in this process of finding the optimum solution, degeneracy arises. This happens when a tie exists. Tandaan mo, ito yung palatandaan. Kapag nakita mo yung tie means tabla, equal. Mamaya malalaman mo yan. Between the two or more entries that represent the smallest on the path of improvement with minus sign, in most negative cell, the following table has an initial solution which is not degenerated. Using MODI method, we will illustrate the example below. MODI method ang gagamitin natin. Okay, so dahil MODI, check ko muna sa balance kung balance or unbalanced. So this is 170 205. This is 5130. Wait. 95 plus 65 plus 35. 15 carry 1. Then 195 lang pala. Okay. This is also 195. So this is balance. Wala tayong problema sa pagiging unbalance. Okay, distribute natin. Nabigay ko yung 50 dito. Dahil 95, bigay ko yung 45, bigay ko yung 35, bigay ko yung 30, 65 na yan. So, bigay ko yung 35. So, we have 1, 2, 3, 4, 5. So, stair-step pattern yung nakikita mo. Yung stair-step pattern yung nakikita mo. So, ibig sabihin, okay. Generated yun. Okay? Kahit maggamit yun ng formula, okay yun. Okay, gawa tayo ng equation. So, B1 plus W1 equals 4. Okay, B1, B2, B3, W1, W2, W3. B1 plus B1 plus W1 equals 4. B1 plus W2 equals 8. B1 plus W2 equals 8. Next is B2 plus W2 equals 4. B2 plus W3 equals 30. No, 8 lang. 4, 8. Okay. Then last is V3 plus W3 equals 16. Okay. Ngayon, let natin B1 is 0. Hanapin natin yung value ng lahat ng B2, B3, W1, W2, W3. Okay, if this is 0, W1 is 4. If this is 0, W2 is 8. If W2 is 8, pay attention. If this is 8, B2 is negative 4. B2 is negative 4. Okay, allowed yun, negative 4 sa value ng B's tsaka W's. Okay, W3 is 12. This is 4. Okay. Pasok lang natin yung values sa loob ng W's tsaka ng B's. So, 0, negative 4, 4, 8, 12. Okay. CFI tayo. Computation for Improvement. 1C, 1, no, 2, 2A, 1C, 2A, 3A, 3B. Okay. So, this is 8 minus 0 minus 12, negative 4. Ang 2A natin, is 8 plus 4. Naging plus 4 kasi negative 4. Minus negative 4. Minus 4 is 8. Ang 3A natin is 16 minus 4 minus 4 is 8. At ang ating 3B ay 4 minus 4 minus 8 is negative 8. So, we choose this, 3B, negative 8. So, hindi pa tayo. So, kung negative 8, so, kung 3B ang hahanapin natin, ibig sabihin, ito yung 3B, ito yung ikot niya, rectangular. So, unaffected yung 50 tsaka 45. Tapos dilipat dito, sino lilipat? Ito yung tie na sinasabi ko. Yung 35, ito yung most negative, 3B. Kung makapansin mo yung adjacent sides niya ay equal. Yan yung tie na sinasabi ko. So, lipat mo yung 35 dito. So, okay. Tapos, lipat mo yung 65. Now, kung mapapansin mo, yung number of occupied cell ngayon ay 4. This will give you degenerated. Sa table number 1, generated siya, pero pagdating sa table number 2, degenerated na siya. So, ang paraan dyan para maging generated, dagdag ka ng 0 entry. Ngayon, sa pagdagdag ng 0 entry, you need to check. Okay? You need to check every vacant cell kung makakaikot sila o hindi. Okay? So, pwede ka magdagdag ng 0 dito. Check natin. Kung maglalagay ako ng 0, makakaikot to. Obviously, 2B makakaikot. Rectangular. Ito naman spider. Ito spider din. Ito spider din. So, nakakaikot. So, pwede kang maglagay ng 0 sa 1C. Ngayon, try natin maglagay ng 0 sa 2B. Sa rectangular, rectangular, spider, rectangular. So, pwede rin. I hope na naiintindihan mo yung sinasabi ko. How about kung maglalagay ako ng 0 sa 3A? Makakaikot si 3A. Makakaikot ba si 2B? Yes. Si 1C, spider. Spider din si 3A. Spider din si 3C. So, pwede. Okay. Okay. Kung dito ka na maglalagay ng 0, ito na, si 2A hindi na makakaikot. Tignan nyo. Kung dito si 2A at lumipat siya dito, wala na siya pupuntahan. So, sa 2A, sa 3A, sorry, 3A ba yun? 2A pala ito kanina. Yung 3A, hindi ka pwede maglagay ng 0. Okay? How about if maglagay ako ng 0 sa 3C. How about 3C? Ito, rectangular. Ito, spider. Ito, spider. Ito, spider. Okay, pwede. So, pwede ka maglagay sa 1C, sa 2B, sa 2A, sa 3C ng 0. Pero sa 3A, hindi. Okay, ganun yung way para ma-check mo kung pwede o hindi. You need to check talaga kung makakaikot ang lahat. Okay? Ngayon, proceed ka lang. Treat mo lang yung 0 entry. Huwag mong, as usual, balance transportation problem na generated. Okay? So, ganun lang yan. Hindi kong tutuloy ito ha. Pinakita ko lang kung paano naging degenerated siya. Pero the procedure is the same lang naman. Okay? Next. Let's talk about the summary on the iteration of the transportation table. Okay? Ito yung number 1. So, number 1, a transportation table is workable only if the total demand quantity equals the total supply quantity. If the number of occupied cells equals the number of rows plus number of columns minus 1. So sa number 1, sinasabi dito, ang transportation daw ay workable kapag generated at kapag balance. Okay? Kapag generated. Kung degenerated, alam mo na para maging generated siya. Maglagay ka ng 0 entries. At kung unbalanced, gamit ka ng dummy. Now, let's go to number 2. If demand is not equal to supply, add dummy supply. Row. If demand is not equal to supply, add a dummy supply row. If demand is greater than, and add a dummy demand column if supply is greater. Okay? So, yan yung way na pag-add ng dummy. Next, number 3. In case of degeneracy in initial solution, use 0 entry in a vacant cell such that a stair-step chain remains. So, yun yung sa initial. Kailangan ng stair-step pattern. Number 4, ito yung huli natin. In the case of degeneracy in the subsequent table, retain a 0 difference in one of the vacant cells, but make sure that all the other vacant will have their adjacent sides at the end of each round. Okay. So, kailangan magkaroon ng ikot ang lahat kung maglalagay ka ng 0. You need to check that. Okay? So, tapos na tayo saan na tayo? Yung TM natin, sabi ko, pwedeng min, max. Sa min, pwede siyang isolve ng SSM, pwedeng modi, pwedeng maging balance, unbalance, pwedeng maging generated or degenerated. Okay. Tama? Ito na lang ang naiiwan natin, yung max. So, paano mag-solve ng max? Basahin natin. Maximization transportation problem. Maximization transportation problem have the same procedure of solving as that of minimization, except that instead of finding the greatest negative value in the CFI, we find the greatest positive value. The reason is obvious. Positive value in the improvement indicates the greatest contribution to the objective. Stop when all the improvement are either 0 or negative. Degeneracy and balance may occur also, and you will follow the earlier discussion to achieve the optimum solution. So, ganun lang pala yan. So, sa maximization, again, pwede siyang MODI, alam mo na yan, pwede siyang SSM. Kaya lang, ang problema dito, ang pagkakaiba nila, di ba, sanay ka sa most negative. Kapag maximization, ang pipiliin mo sa CFI, most positive. Most positive in CFI. Tapos, stop when CFI is either 0 or negative. Okay? So, same procedure lang. So, wala kang problema. So, para ma-practice mo, I will give you this activity. This is leave as exercise. Sakto yung table niyan. 1, 2, 3, 4, tsaka 5. Yan conclusion. Okay? Try mo para ma-practice mo. Wala akong activity na ibibigay ngayon. Ayan ang pang-try lang. Mag-check muna ako ng mga activities na naibigay ko sa inyo sa iba. Okay, next bigyan tayo mga activity. Okay? Okay, so that's all about your transportation. We're done about that. Lahat ng sulok napuntahan natin. As you observe, sana nakakatulong yung video, no? I hope nakakatulong yung video kasi kung aaralin mo mag-isa yan, magbabasa ka ng mahaba, hindi mo pa alam kung tama yung intindi mo. So, make sure na nagpo-provide tayo ng video every topic, no? Mag-aral mabuti, mag-ingat ang lahat, lumalala ang sitwasyon, I don't know kung bakit, may vaccine na, pero sana maging maayos na ang lahat, no? Mag-ingat ang lahat, ha? Mag-aral mabuti. See you sa next topic natin or sa next video natin. Bye!